question number 1. The company C field requires contractors to record the number of hours they work each week. A random sample of 38 weeks is taken, and the number of hours worked per week by contractor Kiana is summarized in the stem and leaf below. Right. So that is the stem and leaf diagram. The quartiles for this distribution are summarized in the table below. Lower quartile is X, which is, we don't know that. Neither we know Y, but we know the median is 26. Okay. Find the values of W, X, and Y. Okay, so first off, we need to be able to locate the median and that. So we know the location of Q2, oh sorry, no, not that. Q2 is usually derived from n plus 1 divided by 2th place. Okay, so this is the location, not the value. So we have 38 plus 38, n, so 39 over 2, which is 19.5. So 19.5 means basically the mean of 19 and 20th value. Okay, so let's count. We have 11 in the first row, 10, that means 19th and 20th both lie in this. So this is 21st, 20th and 19th. So these two values. So the mean of these two values, not 4 and W, it's 24 and 20 plus W because W is a unit. That's the median. Okay, so Q2 we will say is 24 plus 20 plus W divided by 2 is 26. So W is in fact 26 times by 2 minus 24 minus 20. So 26 times by 2 minus 24 minus 20, that is 8. Okay, all right. Now we need to find out the X and Y. Similarly, now we have separated them into 19 and 19. Okay, so 19 plus 1 divided by 2, we get 10th values from either side. So 1, 2, 3, 4, actually we already know this. This is 10th value from over here, and 2, and this one, no, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this corresponds to Q1, this corresponds to Q2. So 19 is Q1, X. Q1 is 19, okay, and Q3 was, we just calculated that, 37. Okay, so in fact, actually, we need to write that process also right here. So we'll just copy this over here. So I'll just keep it in a different color just to Okay, so that is the Q1 and Q3. Okay, Kiana is looking for outliers of this in the data. She decides to classify as outliers any observations greater than Q3 plus 1 times by Q3 minus Q1. Showing your working clearly, identify any outliers that Kiana finds. Okay. Okay, so we need to find out what the upper limit is. Okay, so that is 37 plus 37 minus 19. So 37 plus 37 minus 19, that is 55. Any value greater than 55 will be considered an outlier. So values greater than 55 are 59 and 64. So outliers are 59 and 64. Okay, all right. Then we have, okay, draw a box plot for these data in the space provided on the grid opposite. Use the form, okay, okay. So what I'm going to do, wait, Q3 is 37, Q1 is 90. Okay, all right. So I'll just quickly draw it and then I'll show you. Okay, so I've drawn the boxes, but I haven't adjusted them because let's find out what the minimum is. Minimum value is 14. Okay, so minimum value is 14. So 14 is going to be somewhere right over here. Okay, all right. So this is the minimum value. Okay. Minimum accepted value is was 55. Okay, so 55. Actually, 55. Okay, right. Then we have lower quartile 19, upper quartile 37. So this is somewhat over here, and this is 37 right over here. Okay, so the tail will be this way. Okay, now we need the median. Median was 26. Okay. So 26 is over here. Right. Okay. And now the outliers were 59 and 64. Okay. So 59 is somewhere over here and 64 is over here. That's our box plot. Okay. Right. Let's see what else is needed. Use the formula to find the skewness of the data. Okay. Q3 minus Q2, Q2 minus Q1 and Q3. Okay. All right. So skewness. Okay. Q3 minus Q2, which is 37 minus 26, minus Q2 minus Q1, which is 26 minus 19, divided by 37 minus 19. Okay, so now 37 minus 26, so minus, we have 26 minus 19, divided by 37 minus 19. That is 2 over 9, or in fact 0.222. All right. Kiana's new employer, Landacre, wishes to know the average number of hours per week she worked during her employment at Seafield to help calculate the cost of employing her. Okay. Explain why Landacre might prefer to know Kiana's mean rather than median number of hours per week. So as we see in the skewness coefficient, that skewness coefficient actually came out very close to 0. So that's almost symmetrical data. Almost symmetrical data. So although this may seem like that this is skewed, but this is almost symmetrical data according to the skewness coefficient. There's very little positive skewness over here, very slightly longer tail over here. However, this 14 was not the lower limit; that was the minimum value available to us. So the minimum limit could have been something different. Okay? Similarly, the, it's although not halfway between it, but as we see this is just uh, the difference between the sorry, this I forgot the label Q3 Q2 Q3 Q1. Okay, so the difference between Q3 and Q2 as compared to Q2 minus Q1 is almost just 22%. You can say that. So that's not that big of a deal. So what we'll say over here is that, do we have space? Yes. According to skewness coefficient, the data is skewed very slightly, almost negligible. So mean would be sufficient information for an average, as it accounts for outliers. Okay, so mean accounts for outliers, but median does not. So for an employer, that could be potentially important. All right, okay. So moving on. Question number 2. Oh wait, okay. Number 2. Stewart is investigating the relationship between gross domestic product and the size of the population for a particular country. Okay. He takes a random sample of 9 years and records the size of the population T millions and GDP G billion dollars for each of these years. Okay. The data are summarized as below. And okay, all right. Calculate the product movement correlation coefficient between T and G. Okay, all right. So PMCC will depend on the GT divided by SGST, like that. Okay, so first off, we need all the three values. We have SDG or GT, whatever that is, STT. We need SGG. Okay, so we need SGG. Find out SG, we need SGG. So SGG we'll find out from G squared minus sigma G over N. Okay, so sigma G squared is 362.41 wait 4.41 minus sigma G is, wait, hold on, let's just simply copy this below so I don't have to scroll up and down again. Right, okay, now this is easy. So Sigma g is 144.84 whole squared divided by 9. Okay. So 3624.41 minus 144.84 squared divided by 9. So that is 1293.4516. Okay. So SG, small g, single g, the square root, would be equal to this 35.96458814. Now we find out the PMCC. That is going to be STG divided by STSG. Okay, so STG, they have given us 40.25 divided by square root of 1.29 times by, since I've already done the square root, this. So this is our PMCC. 0.98, sorry, STG was 40.25 divided by square root of 1.29 times by 35.96458814. So this is coming out to be 0.985 PMCC. Okay. Give an interpretation of your product moment correlation coefficient. So we have a strong positive correlation, basically. There is a fairly strong positive correlation between population, between population and GDP. As in, when population increases, GDP would also increase. Okay. Find an equation of the least squares regression line of G on T in the form of G is equal to A plus BT. Okay, all right. G is equal to A plus BT. So B is coming from STG divided by STT. So STG, we actually had it over here, 40.25 divided by STT is 1.29. $31.20. Okay, that is our B. Now we need, let's say 3. Okay, now we need our A. So A can be found by using the mean. So G bar minus B T bar. So G bar 144.84 divided by 9 minus this B times by the mean of T, which is 7.87 divided by 9. Okay, so 144.84 divided by 9 minus Answer times by 7.87 divided by 9. That is minus 11.19068906. So if we want to write it completely, so G is going to be minus 11.19068906 plus B was 31.2015503.9 T. This is with maximum possible accuracy, but we can, tone it down for up to like three uh, significant figures. So G minus 111.2 plus 31.2 T. Okay, all right. Give an interpretation of the value of B in your regression line. So B represents the gradient rate of change. So 31.2. So T was in millions. For E, for every increase of population, for every increase of population by a million, GDP will increase by 31.2 billion. Okay, all right. Use the regression line from part C to estimate the GDP in billions of dollars for a population of 7 million. Okay, so although it's written 7 and 6 zeros, we have to understand that T was already in millions. So this is just 7 over here, not anything else. So DE. So if I want to use, let's use the more accurate one. It's up to us, by the way. So it's up to us. Let me just copy this. So 7, 7. Both are fine, but it's up to your taste over here. This plus 31.2015503.9 times by 7. That is this value, roughly around 207.22. Now let's see if this one comes close or not. Minus 11.2 plus 31.2 times by 7. Again, that is also 207.2. So obviously these things are the same. So however you want to wish. Okay. Comment on the reliability of your answers in part 1. Give a reason and context for your answer. Okay. So so if we see this over here, the sum of the populations for 9 years, okay, so they've just added up to 7.87. So obviously this means that if this is a sum of 9 years, the population, even in the ninth year, it's nowhere near 7 million. Okay, so that's extrapolation. So population is very small compared to 7 million. with the data of which was used for regression line, or sorry, you can say 7 million is very large as compared to population, the data of which was used for regression line or model, basically. Therefore, this estimate required extrapolation which would make this estimate unreliable. Okay. Then we have, using this regression line from part C, Stewart estimates that for a population increase of X million, there will be an increase of $0.1 billion. There will be an increase of $0.1 billion in GDP. Okay. So, see, this is not population of X million, this is population increase of X million. There will be an increase of $0.1 billion in GDP. Okay, so basically they're talking about uh, delta G and delta T over here. So obviously they're talking about the rate of change basically, okay, or the change in GDP with respect to change in T. So we already have the value for that. That is our gradient for this. Okay, so this is our gradient that actually uh, is for that. This represents change in G with respect to change in T. So they're saying that there will be an increase of GDP $0.1 billion. Okay. So change in T would be 0.1 divided by 31.20155,039. So 0.1 divided by 31.20155,039. That is 0.003 million. So we need to give this in millions. Okay, all right. Moving on to next question. Okay, so question number 3. Gil buys a bag of logs to use in her stove. The length L centimeter of the 88 logs in the bag are summarized in the table below. A histogram is drawn to represent these data. Okay. The bar representing logs with length 27 to 30 has a width of 1.5 centimeter and a height of 4 centimeter. Calculate the width and height of the bar representing log lengths 20 to 25. Okay, all right. So first off, we know that the height in a histogram is directly proportional to frequency density, and width is directly proportional to class width, right? So what we can do is we can make it some sort of equation for them because they're simultaneous. So H2 over H1 is equal to frequency density 2 divided by frequency density 1. Similarly, area 2, no, sorry, no, width 2 divided by width 1, class width 2, class width 1. So for that, first we need to find out the frequency densities also. So 19 divided by 5, 35 divided by 5, 16 divided by 2, 15 divided by 3, and 3 divided by 10. So 19 divided by 5, that is 3.8. That is 7. That is 8, 5, and that is 0.3. Right, okay, so now we know the frequency density of this, right? So, okay, let's write this over here. So H2 over H1 is equal to frequency density 2 over frequency density 1. So height 2 is what we are looking for. Height 1 is 4 centimeter and frequency density is 5. So 7 is the frequency density of the class that we're looking for. Okay, so we have 7 times by 4 divided by 5. That is 5.6. Similarly, we need the widths. Class width 2, class width 1. So width 2 will be, they have given us 1.5 centimeter. Okay, and the frequency, no, sorry, the class width is 5 and 3. 5 and 3, and 5 over 3 and 1.5. Okay, so 5 times by 1.5 divided by 3. That is 5 over 2, 2.5 centimeter. Okay, all right. Use linear interpolation to estimate the median of L. Okay, so first off, we need to find out where the location is. So 88 divided by 2. 44. So we need to find out in which class it is. Okay, so 44. So this is going to be in this one, because 19 plus 35, that is 54. So we're looking for this. So, right, so if I, just take a, oh sorry, if I just take a screenshot of this, so I can, paste it below so I don't have to scroll up and down for this. Okay. Okay. So now I can do the linear interpolation. So Q2 minus 20 divided by 25 minus 20 equals to 44 minus 19 divided by 54 minus 19. Okay, so now Q2 will be 44 minus 19, that is 25. 54 minus 19, that's 35, times by 5. So 25 times by 5 divided by 35, that is plus 20, 23.57. Okay. The maximum length of log Gill can use in her stove is 26 centimeters. Gill estimates that using linear interpolation, that X logs from the bag will fit into her stove. Okay, show that x is equal to 62. Okay, so we need, out of 88 logs, we need to figure out how much proportion is less than or equal to 26. Okay, so we need to figure out where 26 is. So 26 is in this bar over here. So we need to use linear interpolation again to figure out where it is. So again, okay, okay. So 26 is in this part. So 26 minus 25, 27 minus 25 equals to, I need to know how much frequency does it, come into this. So we have 54 already. So x, no, let's call that alpha. So alpha minus 54 divided by 70 minus 54. Okay, so this will only tell us how much farther do we have to go. Actually, this would be 8 roughly, but we just want to be sure. So 26 minus 25 divided by 27 minus 25 times by 70 minus 54, and as you can see 8 plus 54, that is 62. So okay, so sorry, that is the x. Okay, so 62. Right, okay, so now we have shown that. Okay. Gil randomly selects 4 logs from the bag. Using x is equal to 62, find the probability that all 4 logs will fit into our stove. Okay, alright, so Gil randomly selects 4 logs from the bag. Okay, so maximum that she can fit in her stove is 62. Okay, right, so all 4 logs. Okay, so all 4 logs would mean that all 4 logs less than or equal to 26. So first one would be how much out of 62? Or no, sorry, 62 out of 88. Then it will be 61 out of 87. Then 60 out of 86. And then finally 59 divided by 85. Okay, because she's taking out of her logs over here. Yes, okay. 62 times by 61 times by 60 times by 59 divided by 88 divided by 87 divided by 86 divided by 85. So that comes up to be 0.239. Okay, all right. The weights W grams of the logs in the bag are coded using y is equal to 0.5 W minus 255 and summarized by that. Okay, calculate the mean of W. Okay, so when we have this equation, again, let's paste this. So first off, we have the equation y is equal to 0.5 W minus 255, just to make sure that, yes, that was the case, yes. Okay. Then we have the data. Okay, so we know, which part was it? E part? E part 1. Okay. Now for the mean, we know that y bar will be equal to 0.5 w bar minus 255. So to find out w bar, we just have to do y bar plus 255 divided by 0.5. So y bar, so basically 0. Divided by 0.5 means times by 2. So y bar is 924 divided by 88 plus 255. Okay, so 924 divided by 88 plus 255 times by 2, that is 531. Okay, next up was the variance of W. Okay, so we know that if y is equal to 0.5 W minus 255, so sigma y squared, or the variance of y, will be 0.5 squared times by sigma, W squared. So basically this means that sigma W squared is going to be equal to 0.5 squared times by sigma y squared. So 0.5 squared. Now we need to find out the sigma y squared, or just the variance. So that is 12862. Actually, let's write the formula first. Y squared minus sigma y over n whole square. So that is 0.25. Actually, that will be just equal to 4. Sigma y squared, they gave us 12862 minus the square of sigma y, which is 924 over 88. So 924 divided by 88 squared, 12862 minus answer times by 4. That is, no, wait, sorry. This obviously some mistake. Sorry, I forgot this 88 over here. My bad. Sorry. 12862 divided by 88 minus the 924 divided by 88 whole square. That is this times by 4. That is, okay, 143.6. Right, okay, so that's about it for the question number 2, E part 2, sorry. Yeah, okay. All right. Moving on to question number 4. The events H and W are such that probability of H is equal to 3 by 8 and H union W is 3 by 4. Given that H and W are independent, so independence means that probability of H intersection W is actually just the product of H and W, the individual probabilities. Okay, so all right, okay, so let's write this over here. Since H and W are independent, probability of H intersection W is just the product of their individual probabilities. Okay, so probability of H union W would then just be simply probability of H plus probability of W minus the product of H times by probability of W. Right, okay. So they told us that probability of H is 3 by 8 and the other one is just 3 by 4. 3 by 8 plus probability of W minus 3 by 8 times by probability of W. Okay, so 3 by 4 minus 3 by 8 equals to probability of W 1 minus 3 by 8. So 3 divided by 4 minus 3 divided by 8 is 3 by 8. Probability of W is 1 minus 3 by 8. That's going to be 5 over 8. So as you can see, 8 gets cancelled. So probability of W would just simply be 3 by 5. Okay, the event is N is such that probability of N is 1/15th and probability H intersection N is just N. Okay. So find the probability of N complement given H. N complement given H. Okay, all right. So N complement given H. So probability of N complement given H can be rewritten as probability of N complement intersection H divided by probability of H. Okay, so now to understand this, to find out the numerator over here, we have to see this relationship over here. Okay, so this, if we want to actually, write an alternate form in the form of conditional probability over here, we could have also written it like probability of N given H times by probability of H. That will be the probability of H intersection N. So if we look at the data that's given to us, probability of H is 3 by 8 and probability of N is 1 by 15. So basically, let's take this below. Okay. So probability of H was, and probability of N was, I guess, sorry, I keep forgetting, 3 by 8 and 1 by 15. Right, okay. So if we can find the probability of N given H from this, okay, so let's do this. If that is equal to probability of N, okay, so probability of N given H will be probability of N divided by probability of H. So 1 divided by 15 divided by 3 by 8. That is 8 by 45. So we know that N complement given H and probability of N given H will be mutually exclusive events equals to 1. The sum equals to 1. So probability of N complement given H will be just simply 1 minus 8 over 45. That is 37 over 45. Okay, given that W and N are mutually exclusive means that probability of W intersection N is 0. Draw a Venn diagram to represent the events H, W, and N, giving the exact probabilities of each region in the diagram. Right, okay, so let's draw a table, sorry, Venn diagram. Okay, so we had A, W, and N are mutually exclusive. So we have at least two events that are not intersecting. Okay, so let's say this is W, this is N. Okay, then we have H. Sorry, that was three events, right? H. So H is intersecting with W. Okay, okay, and we also know that one thing. There was one another thing over here. Oh, right. The probability of H intersection N is equal to probability of N. So intersection between H and N is N itself. So basically N lies in the H. Okay. So if I increase the size, if I redraw this is H, this is N, and this is W. This is N, this is H, and that is W. Okay. Right, okay. Now we need the probabilities. Okay, so probability of N was 1 by 15th. Okay. Then the probability of H intersection W, that was probability of H times by probability of W. So 3 by 5 times by 3 by 8. So that is 9 over 40. Okay. So this is 9 over 40. Now we just need to subtract from W. The probability of W was 3 by 5. So 3 by 5 minus answer, that is 3 by 8. Okay. But the probability of H will be subtracted by 940 and 150. Oh, this is the H alone. So H was 3 by 8. Okay. So 3 by 8 minus 9 over 40 minus 1 over 50. We get 1/12. Okay, now finally just checking that they indeed add up all to 1 plus 9 divided by 40 plus 1 divided by 12 plus 1 divided by 15. 3 by 4. So that means 0.75 is outside. Okay, all right, just to make sure that we haven't missed anything. Right, so that's about everything. No, sorry, that's 0.25. Sorry, that was the sum. So it will be 0.25 over here. Okay, sorry, my bad. Right. Okay, so question number 5. Okay. A red spinner is designed so that the score R is given by the following probability distribution. Show that ER squared is 15.8. Okay, so I'll just copy this and paste it below so I don't have to scroll up and down again. Okay, so we need the ER squared, right? Right, okay. So all these values squared, 4, 9, 16, 25, 36, and then times by their respective probabilities. 4 times by 0.25 plus 9 times by 0.3 plus 16 times by 0.15 plus 25 times by 0.1 plus 36 times by 0.2. Okay, so 4 times by 0.25 plus 9 times by 0.3 plus 16 times by 0.15 plus 25 times by 0.1 plus 36 times by 0.2. So that is 15.8. Right, sure. Given also that ER is 3.7, find standard deviation of R. Okay. So first off, we will find the variance of R. That is going to be ER squared minus the square of expectation of R. So that is 15.8 minus square of 3.7. What was it, 3.7? 3.7, yes. Okay. Minus 3.7 squared. That is 2.1. So standard deviation of R, or sigma R basically, is going to be the square root of this, 1.453. Okay, all right. Two decimal places, so 4, 5. Okay, moving on. A yellow spinner is designed so that the score y is given by the probability distribution in the table below. The cumulative distribution table of y is also given. Write down the value of d. It's simple. That it's going to be 1 because the last fy becomes probability of all values less than equal to 6. So if these are all of the possibilities, then it should be equal to 1. So d is equal to 1. Given that E of y is 4.55, 4.55, find the value of C. Find the value of C. Okay. Okay, all right. So let's take this below and let's work on this. They said that EY is 4.55. So if we just, make a arbitrary equation for that, that's going to be 2 times by 0.1 plus 3 times by 0.2 plus 4 times by 0.1 plus 5a plus 6b. Okay, we've already figured out that d is equal to 1, and that is equal to 4.55. So if we make a linear equation in this, that will be 2 times by 0.1 plus 3 times by 0.2 plus 4 times by 0.1 plus, that's it. And then 4.55 minus answer, that is this. So 5a plus, wait. Okay, all right. 6b is equal to 3.35. Okay. Another equation that links a and b is this, is that all the probabilities should add up to 1, which means that 0.1 plus 0.2 plus 0.1 plus a plus b should add up to 1. So this means that 0.1 plus 0.2 plus 0.1, 1 minus answer, that is 3 by 5. So a plus b is equal to 0.6. Okay. Now that we have these, let's find out what's a and b. So 5a plus 6b is equal to 3.35, and a plus b is equal to 0.6. Okay, so if I multiply simply both equations by 6, 6, I can find out what at least one of them is. So minus, minus, minus. So I have minus a is equal to 3.35 minus 0.6 times plus x. That is minus 1 over 4. And this means that a is 0.25. B would be 0.6 minus 0.25. That is 0.35. Okay, now finding the C is going to be easy because C adds up all the probabilities up until 5. So 0.1, 0.2, 0.1, and A. So therefore, C is going to be 0.1 plus 0.2 plus 0.1 plus A. So that is going to be simply 0.1 plus 0.2 plus 0.1 plus 0.25, that is 0.65. Right. Okay. Pavel and Jesse play a game with these two spinners. Pavel uses red spinner. Jesse uses yellow spinner. They take turns to spin their spinner. Okay. The winner is the first person whose spinner lands on the number 2 and the game ends. Jessie spins her spinner first. Find the probability that Jessie wins on her second spin. Okay, red spinner, wait. So we have red spinner over here, yellow spinner over here, okay? But the probabilities are different. So Jessie has yellow, okay? So let's make a tree diagram, just, temporarily over here. So Jessie, yellow. So either it's 2 or not 2. And for Pavel, who has red, either it's 2 or not 2. Either it's 2 or not 2. Second attempt for Jesse will be after that, 2 or not 2, basically. Okay, so Jesse winning on the second try would be, sorry, my bad. This would be over here, 2. So not winning, and so not 2, and then, okay. So probability will be not 2 for Jesse, not 2 for red, and then 2 for yellow. Okay. So not 2 for yellow, that is just simply 0.9. Okay. And not 2 for red, that is going to be 0.75. Okay. So we have 0.9 times by 0.75 times by 0.1. Jesse, second try. So that's that. So 0.9 times by 0.75, 0.1, that is 0.0675. Right, okay. Calculate the probability that in a game, the score on the pebble's first spin is the same as the score on the Jesse's first spin. So basically, we're talking about 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Although from the context of this game, we know that if either one of them scores 2, that will be done. So we are only focusing on 3, 3, 4, 4, 5, 5, and 6, 6. Okay, so we need both of the tables this time. Right. Okay. So we have probability of, actually let's see this over here. 0.3 times by 0.2 plus 0.15 times by 0.1 plus 0.1 times by A, we calculated it as 0.25 plus 0.2 times by B, we calculated it to be 0.35. So that is 0.17. Same number. So 0.3 times by 0.2 plus 0.15 times by 0.1 plus 0.1 times by 0.25 plus 0.2 times by 0.35. That ends up to be 0.17. Right, okay, so that's this question. All right, moving on. Question number 6. A manufacturer fills bottles with oil. The volume of oil in a bottle, V milliliters, is normally distributed with V normally distributed 100 and 2.5 square. That is 2.5 is standard deviation. Find find the probability of volume greater than this. Okay, so straightforward. V greater than 104.9 is equal to 1 minus probability of V less than 104.9, and this can be converted into standardized form. 104.9 minus 100 divided by 2.5. So 4.9 basically divided by 2.5, that is 4.9. 1.96. 1 minus probability of Z less than 1.96. Okay, so let's go into the table and find this. Okay, so 1.96 is over here. So 1 minus 0.979750. Okay, so going back, one over 40, which is 0.025. Okay, all right. In a pack of 150 bottles, find the expected number of bottles containing more than 104.9. So basically, we have already found out that this is going to be the proportion in a sample, right? So the proportion or probability of finding that. So B would be just simply 0.025 times by 150. That is roughly around 4. Okay, Find the number of v to two decimal places such that probability of v greater than small v given that less than 104.9 that is equal to 0.2801. Okay, so let's expand what that really means. That expands to probability of v less than 104.9 divided by probability of v less than 104.9 is equal to 0.2801. So first, let's simplify by taking it on the other side and splitting this all up. So we have probability of v less than 104.9 minus probability of v, sorry, small v less, v less than small v equals to 0.2801 times by probability of v less than 104.9. We actually calculated or found that probability that was 9750, so we don't have to do it again. So we actually found it two places. So that was 9750. 0.9750 minus probability of v less than v equals to 0.2801 times by 0.9750. So probability of v less than v would be just simply 0.9750 times by, minus 0.2801 times by 0.9750. So that is 0.701925. Okay, so we standardize this. So obviously, wait. Okay, all right. First off, let's keep this 3.75. Okay. Right. So let's see. Right. So when we standardize this, this would be equal to z less than v minus 100 divided by 2.5 equals to 0.7019025. Okay, let's go back into the table and find this. Okay, so we're looking for 0.701. 7019. So 0.53. I think we can, up to 4 decimal places, this is fine. So we can, call it today 0.503. So v minus 100 divided by 2.5 is 0. Sorry, I forgot what that was. 53, sorry. Okay. So 2.5 times by 0.53 plus 100. That comes out to be 101. 325. And that's about it. Alright, so that's the end of this paper. Hopefully I'll see you next time.